our fourth module. This is the finite difference and interpolation. Now in this we will see the forward difference, backward difference, central difference. We also see the symbolic relationship and the Newton's method interpolation of unequal interval Lagrange's polynomial. So these are things which we will learn in this particular module. So let's start. Now before we can begin with this thing, we need to understand what are the symbols. There will be few symbols that will be used in order to calculate, in order to find out the desired values. So let's see what are the difference operators available. Now before that, you need to understand that we are going to apply these operators on our equation. These equations are in the form, suppose y is equals to f of x. Now this f of x can be anything. This f of x, it can be anything. It can be your simple x, or it can be your x cube plus 3. It can be your 2x square plus 7x plus 3. It can be any equation, doesn't matter. When I apply the operators on the equation, there are certain things that are going to change. Number 2 point, you need to understand that the intervals will remain the fixed in here. Assuming fixed interval. Later on we will discuss with unequal interval also. Now this x, these are the data sets. Now since h is fixed, so they will be equidistant. Meaning if the first value is 2 and my h is 0.1 and my h is 0.1, then what is the next value after 2? It is 2.1. What is the next value after 2.1? It is 2.2. It's 2.2. What is the next value after that? It is 2.3. And that's the reason we have mentioned over here that x1 is equals to x0 plus h, x2 is equals to x1 plus h. And what is your x1? It is x0 plus h, so it is basically x0 plus 2h. Similarly, x3 is equals to x0 plus 3h. So we can make a general equation as xn is equals to x0 plus nh. So if it is 3, then 3, it is 2, then 2. Similarly, if it is my h length is of equal interval. Now let's see what are the operators available. The first operator is shifting operator. It is denoted by capital E, shifting operator. So whenever I apply my shifting operator, suppose this operator, whenever I apply this shifting operator on my equation, whether I apply it on y or f of x is the same, so I applied it on it is shifted by h, the equal interval. So whenever I apply E on my f of x, my f of x is shifted to x plus h. Now if I apply my shifting operator square, E square on f of x, then what happens? It is shifted by 2 times of h. Similarly, if I apply e to the power half on f of x, then it is shifted by h by 2. If I apply minus 1, shifted by minus. So that is how shifting operator works. So whenever you apply your shifting operator on the function, it is shifted by the equal interval, depending upon whether it is 1, whether it is 2, whether it is half, or whether it is minus half. Now let's see what will happen. Now suppose y is equals to f of x is my equation. I applied my shifting operator on y naught. What is y naught? Y naught is your first value of due to x naught. So for x naught data, I am getting this y naught. So that is my first value. I have applied. So whenever I apply that, these are the same thing. E is equals to f of x naught. And what happens when I apply my e? Since there is 1, so it is x naught plus h. And what is the meaning of x naught plus h? The meaning of x naught plus h is x1. Means x1. So it is, what is f of x1? It is basically y1. So when I have applied my e, when I have applied my e on y naught, it becomes the next value, which is my y1. So when I applied my e on y naught, it becomes y1. Similarly, if I apply my e on y1, it becomes y2. If I apply e inverse on y1, then it moves back. That's from my shifting operator. The next operator that we have is our forward difference operator. Now this is important. All are important, but this is something which I will specifically see. In today's video only, we are going to see the forward difference, how we can apply that. So forward difference, when I apply this delta on my function, I have applied this delta on my function, it means that it is f of x plus h minus f of x. So this is the definition for forward difference. F of x plus h means the next value minus the previous value. If it is square, del square f of x, and what happens? Del on del f of x. And what is del f of x? It is f of x plus h minus f of x. Then it is basically del f of x minus del f of x. What is the meaning of del f of x? It is the next value. See, it was h, so it now became twice h minus this, and over here is. If you do it, then you find that del square f of x is equals to f of x plus 2h minus twice f of x plus h plus f of x. You don't have to remember them, but if you practice a lot, then it will be in your memory only. So how to write it in terms of y? If y of f of x, if I apply del, what happens is del y naught. What is y naught? Is the initial value. So it becomes here del f of x naught. F of del of f of x naught is basically f of x naught plus h minus f of x naught. And what is x naught plus h? What is your x naught plus h? It is the next value of x naught, which is basically your x1. So that's what we are making. And what is f of x1? This is still y1. Del of y naught is y1 minus y2. You will get a clearer picture when you use the numerator. Don't worry about that. Similarly, del of y1 is equals to y2 minus y1. Del of y3 is equals to y3 minus y2. If I apply the del square, you can see how we have done it. We get the same thing. So these are the same thing only. So this is the same thing. The representation is different. Over here it is in terms of f of x. Over it is in terms of y. Now we also have a backward operator. The symbol is this. So as the name suggests, it is a backward operator. So it is the initial value. It's the move backward. So backward operation. As you can see over here. The procedure is same. I will suggest you and I will recommend that you. I will provide you the PDF, but you do it on your copy. So you do each and every step on the copy, and you will get a clear idea about how things work out. So I've done it. I've written everything over here. You also have a central operator represented by del. It is defined in this way: f of x plus h by 2 minus f of x minus h by 2. We also have an averaging operator which is mu, which is represented in this way. So the difference between the central and this is that in central operator there is no half, in averaging operator there is half. An average. So these are the 5 most common operators that are applied on our function. So what are they? They are shifting operator, we have forward difference, we have backward difference, we have central difference, averaging difference. So what does the operator do? Operator changes the equation. It adds a value, or it subtracts a value, and it changes the your equation. Keep that in mind. We also have a topic called the symbolic relationship. What is the relationship between all of them? Means what is the relation between your forward difference and your shifting difference, the backward difference and shifting difference? So these are the most common 8 formulas which you can find out. These will be used later on while solving the numericals. Now, how we have derived this? I have done the derivation for all of them. You will find it in any other book also, but I have done it for you. I will show you 1 and 2. The rest follows the same procedure. Again, I'm saying it. Though I will be providing with the PDF, I highly recommend that you do it on your copy. Okay, only when you write you will remember and understand it in a better way. So how did we find del with respect is equals to e minus h? Now let's see. What is your del of f of x? Let's see over here. What is the meaning of del? Del is a forward difference, isn't it? So what is del of f of x? It is f of x plus h minus f naught fx. That's what we have done. Del of f. And what is your f of x plus h? Just go through your shifting operator. Just go through your shifting operator. f of x plus h. What is f of x plus h? As you can see, what is f of x plus h? It is basically e of fx. That is what we have done over here, isn't it? See, this f of x plus h. This with respect to e, what it is? F of x plus h is basically e of f of x. That's what we have done. E of f of x. Now from here we can take f of x as common. It is e minus 1. We have f of x over here. We have f of x over here. Just subtract them. You get that equals to e minus 1. Similarly, in the backward difference also, what is the formula for backward difference? You can see over here. Backward difference f of x minus h. See, that is what we have done it over here. Now, what is f of x minus h with respect to e? See, f of x minus h with respect to e, what did we find out? F of x minus h, f of x minus h with respect to e inverse. Just take f of x common, you will find it. So in this way, just go through the formulas, you will be easily able to calculate all of them. I have derived all of them for you, so you can do it. And also written how we have calculated them. So use the previous relationship to find out the next relationships. If you face any problem, do ping me on my WhatsApp number. I will clear it out. What is f of x plus h? If you expand the f of x plus h with respect to Taylor's theorem, this is what you get. We have already gone through it. Okay. Now, if the intervals are equal, then we have three ways of finding out the values: Newton forward interpolation, Newton backward interpolation, central interpolation. If they are unequal, then we have the Lagranges and the Newton dividend operator. We have them. We will discuss them later. Today we will see the Newton forward interpolation. Now, what is the difference between interpolation and extrapolation? I mean, in a very simple term, suppose we have a data set. Suppose this x, I'm taking equal intervals. See x naught is 1, this is 2, this is 3, this is 4, and in this way I am having till 10. These are the values of x. Now, for 1, I am suppose my x value is 4. For 2, my x value is 7. For 3, my x value is 8. For 4, my x value is 10. And for 10, my x value is suppose 0. Now I ask you to find out the value of y for 1.3. Now 1.3 value you don't know. X 1.3 is not given to you. X1 is 4, X2 is 7. But what is X 1.3? Now X 1.3 lies between your data sets of 1 and 10, isn't it? So it is interpolation. Now if I ask you to find out y, suppose 12, what is y 12? Now you have the data set from 1 to 10 only. You have the values of y for x of lying between 1 and 10. You do not have anything beyond that. So this is extrapolation. Why? Because it's beyond your data set. The formulas that we'll be discussing, like the Newton forward, backward, these all of them are same for both interpolation and extrapolation. That doesn't matter. I mean the procedure is same, everything is same. Just I mean one is called as interpolation if my value is within the data set. It is called extrapolation if the value is beyond the data set. Now, in order to find out the Newton's forward difference formula, we first need to make the forward difference table. So we will see that this is for equal interval only. Just keep that in mind. Now, in order to calculate my y from my forward difference, which is delta, this is the formula which is used. Y is equals to f of x is equals to y naught plus p del y naught. What is this del y naught? This is the forward difference of y naught. Then p minus 1 by 2 factorial del square y naught. This is second forward difference of y naught. So in this way we can find out what is your y. What is the meaning of p? P is x minus x naught divided by h. So basically your x is equals to x naught plus ph. Now in order to calculate it, see, as I have told you, you will be given a data set. In such kind of problems, you will be given a data set. Now from this data set, I need to calculate my difference table. So let me take, there are 5 data sets: x0, x1, x2, x3, x4, x5. Correspondingly, I have my y0, y1, y2, y3, y4, y5. Now what is the first forward difference? As you know, it is basically del of y naught is y1 minus y2. So this minus this. Similarly, del of y2 it is this minus this. Del of y2 is this minus this. So in this way you have this first forward difference. What is the second forward difference? The second forward difference will be this del y1. Second forward difference will be del y1, meaning this value minus this value. Similarly, in this way, if you continue, you can make the forward difference table. So let's see with an example. Suppose I have these values, find the cubic polynomial function. I have x as 0, 1, 2, 3, 4. What is h over here? H over here is 1. How do I know it? Because this 1, it is basically 0 plus 1. What is 2? It is 1 plus 1. What is 3? It is 2 plus 1. So this is equal interval. So, and what is the corresponding y? Y which is equals to f of x is 1, 2, 1, 10. Now I am asked to find out what is f of 4. This is means x is 4, so it is extrapolation, and also f dash 4. So let's start with this. First we need to make the forward difference table. Remember, so what do I have over here? X is 1, 0, 1, 2, 3, and y is 1, 2, 1, 10. So I've written them 1, 2, 1, 10. This is my first forward difference. What is the del y naught? It is this value minus this value. Del y2 is this value minus this value. Del of y2 is this value minus this value. So that's what we have done over here. This is the first forward difference. Now, as part the formula, please pay attention. As part the formula, you only need this y naught. Del y naught, this del y naught, this del y naught. These are important to you. So keep that in mind. So from your this particular table, this value del y naught is important to you. But you do need this del y1 and y2 in order to calculate your del square y naught. Again, you need this del square y naught and del square y1 to calculate del square. These are basically this minus this. This is the difference table. So I have my values, which are del y naught is 1, del square y naught is minus 2, and del cube y naught is 12. So I have made my forward difference table. Now, what is my p? P is x minus x naught by h. So what is your x naught? What is your x naught? X naught is 0. So you have put it 0 over here. What is your h? The difference is 1 only, isn't it? So I put it 1. So p is equals to x in this case. Now this is the original formula. This is the original formula f of as per the Newton's forward difference interpolation. So just replace the formulas with their values. What is your y naught? Your y naught is for x naught you have y naught as 1. So I have put 1 over here. What is your p? As per this my p is x. What is del y naught? The del y naught is 1. So I put 1. Similarly, what is p? It is x. What is p minus 1? It is x minus 1. It is 2 factorial, so it is 2 into 1. What is del square y naught? It is minus 2. So I put minus 2 over here. Then p, x. P minus 1 is x minus 1. P minus 2 is x minus 2. 3 factorial is 3, 2, 1. And what is del cube y naught? It is 12. Then do the calculations, you will find your function f of x. Now once you have this function, what you need to calculate? You need to calculate f of 4. Just replace x with 4. Just replace x with 4 and you can calculate what is f. Now if you want to find out what is f dash 4, just differentiate this f of x. Then what it will be? It will be 6x square minus 14x plus 6. Then replace this x with 4. You can find your do it yourself. This is not a homework, but do it yourself. Thank you.